So what is a cloud forest? Basically, it's a tropical or subtropical evergreen montane forest, okay, where there is a high incidence of low-level cloud cover, normally at canopy level, okay? In other words, a cloud forest is when we have a mountain, let's say a volcanic mountain range, okay, like this. A cloud forest is the ecosystem that you find at the very top, okay, of this mountain range. And why is it so special and why is it so endangered? Well, we're going to study some of those characteristics that makes it so special and so endangered. But one of the most important characteristics is that, you know, the humidity is very high, okay, throughout the year, and also the solar radiation is not as intense as it is down here, okay, in the lowland rainforest. That's why when you go, for example, to La Selva Biological Station, for those who have been there, it's like, oh, like so hot and humid there. But all of a sudden, like, you get on the bus and like then you go up to Monte Verde and it's nice and cool and you can wear a fleece jacket and, you know, drink coffee, and so it's really, really nice. And so basically, that's a more, you know, like a very common definition of a cloud forest. Another characteristic, another way how people call cloud forests, or another reference for cloud forests, is that for many ecologists, cloud forests are islands, okay? Because imagine if instead of having water, okay, like salt water, you have high temperature here, okay? So this ecosystem is isolated, let's say, in a sea of hot, okay, lowland rainforest. And so one of the things that I have heard from my friend Terry is that they're thinking maybe in like reducing or limiting the amount of people going to the Galapagos, okay? The Galapagos is a series of islands off the coast of Ecuador, and one of the reasons why they're thinking, you know, taking that, you know, conservation measure is because the ecosystem is so fragile, because the ecosystems there, you know, if it is too exposed, let's say, to a lot of traffic, like it can, you know, be destroyed. And so that's something that we have to deal with in a daily basis in Monte Verde, because, you know, as we're going to see later, one of the features of Monte Verde is that it's an ecotourism hotspot, and like now, like besides students, like we also get like a lot of visitors who are necessarily not interested in studying the cloud forest, but just saying that they're visiting the cloud forest, and that could be, you know, a double sharp tool, because it could be good for the economy, but not necessarily good for the ecology of the place. Okay, so cloud forests are not only found in Costa Rica. Like this is basically the distribution of cloud forests, you know, in the Americas and even in Hawaii. Okay, there is cloud forests. We also find cloud forests in the eastern part of Africa, and the western part of Africa, and in Southeast Asia. Okay. Okay, what are some of the characteristics of the cloud forest? Well, basically, one of the things that I mentioned before is that it's an ecosystem that is almost year-round, you know, and basically touched by the clouds. It has like the blanket, let's say. It has a blanket of clouds on it. And so it's important to understand, you know, the mechanics of the clouds and the incidence that they have, a repercussion that they have in the ecosystem. It's important to understand how clouds are formed. So basically, during the rainy season, which is from May through October, we have the sun, you know, irradiating almost at 90 degrees on top of us, okay, on top of Costa Rica. And so that produces essentially, you know, clouds, because what happens is that it's hot and sunny in the morning, and that, you know, at that time the potential evapotranspiration, okay, of the water, that is, you know, basically the sun is pulling the energy, okay, from the ecosystems, and then like in the afternoon, okay, when the sun goes to sleep, essentially what happens is that the air temperature is reduced, okay, significantly, and so there is condensation and cloud formation. And so that's how clouds are formed during, okay, this time of the year. And then at the end of the day, usually by 4 o'clock, by 5 o'clock, when it's really cool, okay, when the environment has cooled down, it pours, okay? And then like basically is the way how the clouds return the water, okay, back to the system, and then the next day is the same cycle, okay? Well, but that only happens during the rainy season. During the, let's see, transition and dry season, which extends from November through April, more or less. Right now is the end of the dry season in Costa Rica. We have a lot of wind that comes from the north, from the northeast, and basically we have a very interesting phenomenon here, because as the wind blows in this direction from the Caribbean, it picks up humidity, okay? It picks up humidity from sea level, from the air, and so since we have these tall mountain ranges here, because for example Monte Verde is almost a mile high, okay, from sea level, a lot of the humidity is forced to climb that mountain. And what happens when you climb a mountain? The temperature drops, okay? And so there is condensation and cloud formation here. And so at the end, we have, you know, like a constant mist, okay? Like hitting the cloud forest that is, you know, and that mist basically is like air coming from the north, from the northeast, and then like being, you know, dropped on top of the cloud forest. And so that's how clouds are formed during that time of the year. So what are some of the characteristics of the cloud forest? Like having, you know, all of those environmental patterns happening there, it creates, you know, a series of differences, okay, when you compare the cloud forest to the lowland rainforest, okay? If you remember the life zone maps, okay, you might think, okay, well, I thought that Costa Rica and the tropics was just like jungle, okay? Well, it's not just like jungle, okay? There are many different types of ecosystems, and temperature, humidity, elevation, geography, climate in general basically shape how an ecosystem is, how the phenotype, let's say, of the ecosystem expresses itself, okay? And so that's how it works. And so in this diagram here, that it looks complicated, but in reality it's really easy to interpret. Well, we have, imagine that here is 0 meters above sea level, and here is about, you know, 3,000 meters above sea level or higher, which is like 11,000 feet, okay? So it's like climbing the mountain, okay? So the elevation changes from sea level. As the elevation changes from sea level, you can see that, for example, the temperature drops, okay? From hot down here to cool up here. Lower montane cloud forests are located here and here. The solar radiation is less in the mountains and more down here. Why? Because we have clouds, okay, covering the forest, and therefore, you know, the sun is not able to penetrate directly. Obviously, we have more clouds as you climb the mountains because there is more condensation. Okay, so it's a very, very simple diagram that helps us understand the cloud forest. And as you can see, the height of the forest also is reduced as you climb the mountain. Okay, here, for example, in La Selva Biological Station, which is one of the stations where TUSA students go, is like 45 meters. Okay, the trees are very, very tall. And here in Monte Verde, in the cloud forest, the vegetation is you know, much shorter and more dense and more compact. So basically, what you get is this. Okay, so this is the type of environment where I live. Some other characteristics is that as you climb the mountain, okay, in this direction, we get more epiphytes. Epiphytes are plants that grow on top of other plants without causing necessarily a direct damage to the host plant. Okay, so it's very dark down here, okay, in the forest floor. And so many plants have adapted themselves like to survive on top of the trees. And so as you climb the mountain, okay, up to the cloud forest, you'll find that there are more epiphytes. The evapotranspiration is less, obviously, because there is a cloud covering this ecosystem here, and therefore, you know, the plants, it's like being with air conditioning all the time, basically. The decomposition rate of the organic matter that falls from the, from the trees and from the vegetation is also much less because there is less temperature, okay? It's cooler down up here, and therefore the metabolism of the ecosystems are much slower, okay? It's like coming to the north, okay, from the equator. Basically, it's the same effect. And the soil accumulation in the A horizon, you know, the organic soil, the mulch, okay, is much more here precisely because of the decomposition rate is much smaller, okay, or is reduced compared to the lowland rainforest. So one of the things that a lot of people think about the rainforest is that the soils are very fertile, they're very rich, okay? That is not true. There are lots of nutrients in the soil, but every single little bit of nutrients are used and are available up in the vegetation, but not in the soil, okay? So that's why deforestation is such a, you know, such a problem in the tropics, because once you remove the vegetation, basically you're taking away, you know, all the nutrients, okay? And then like it takes tons of years, like hundreds of years for that soil to restore itself, okay? So this is how the cloud forest looks like from a close-up. Another characteristic is that, well, you might think, well, if it is cooler, if it has clouds, if it is more like moist, does it have less biodiversity than the lowland rainforest? Not necessarily, okay? Because something that happens in the cloud forest is that a lot of endemic species, okay, show up. A lot of endemism shows up. What is endemism? Endemic. When a species is endemic, it means that it only lives in one area, okay? And so here we go to the island biogeography theory. Basically, Darwin, okay, the person who, one of the two who discovered or put together the theory of evolution through natural selection, one of the things that he saw in the Galapagos is that in each island, okay, there was a different type of finch, a different type of bird, basically, that had the beak adapted to the food that was available in that island, okay? And so the species here was different from the species here, but they had the same parents, okay? And so what happens in cloud forests is basically the same, because, you know, maybe we have a species of tarantula that goes here, okay? And then another species, the same species of tarantula that goes here, and the same species of tarantula that goes here. Well, the one here becomes isolated, okay, from the one here, and maybe there is more food, or there are some characteristics of this forest here that might make it, you know, evolve and become a new species different from the parent species and different from this species. And so the fact that endemism is present in cloud forests is one of the main reasons why the biodiversity is still very high, sometimes higher than in the lowland rainforest. So here we have some examples of endemic species that we can find in Monte Verde. This is a tarantula, an orange-knee tarantula that is endemic to our area. We have a tree in the bean family that is called Stipnolobium monteveridis. So basically, it only lives in Monte Verde. And this is the golden toe, which is one of the extinct species that we have in Monte Verde. And extinct means that it was there and it's not there anymore. It disappeared, and we'll talk about the reasons for that later. Okay, so, and as I said, the biodiversity is very high. We have more than 3,000 species of plants. We have, including 500 species of orchids, 700 species of trees. We have more than 150 species of mammals, only in Monte Verde, more than 400 species of birds, many amphibians, many reptiles, and we don't even know how many insects, okay? So basically, this is just for Monte Verde, the cloud forest where we live, okay? Where we live and where I work. And so that's another, you know, very important feature of this type of ecosystem. So now, let's go really fast through some of the remarkable species. This is the resplendent quetzal. This bird is, you know, is one of the most beautiful, amazing species of birds that we have in the cloud forest. And it's an altitudinal migratory species, okay? This bird comes to Monte Verde to breed, okay? And to, you know, spends like certain months during the year only in Monte Verde, basically for reproduction. purposes, and then like it goes down to the lowlands, following the fruiting patterns of wild avocados, which are, you know, in a family called Araceae, and that are very common in Monte Verde, and that's the reason why it comes.